When two lines on a graph cross at exactly 90 degrees, the geometry snaps into focus. It is a precise, ordered intersection. Achieving that perfect right angle requires specific algebra, especially when starting from a fixed line and a point floating elsewhere on the grid. For this problem, we are starting with an original line described by the equation x minus 2y plus 3 equals 0. Our target point is located at -1, 2. The goal is to calculate the exact equation of a new line. This line must pass through our target point while remaining perpendicular to the original orange line. To solve this problem, we will translate the visual requirement of a right angle into a set of algebraic steps. The first step is to find the slope of the line we already have. We do this by looking at the general form of the linear equation. By aligning our equation with the general form, we identify the variables. A is 1, B is -2, and C is 3. Now we use the slope formula, stating the original slope, m1, equals -a divided by b. We substitute our values into the formula, being careful to track the negative signs. We have -1 divided by -2. The two negatives cancel out, giving us a starting slope of exactly 1/2. Identifying this original slope is the necessary starting point for plotting the new trajectory. Finding the first slope provides the exact value we need to determine the second, based on how perpendicular lines interact. For two lines to be perpendicular, the product of their slopes must always equal -1. We plug our original slope of 1/2 into this rule to solve for our new slope, m2. To isolate m2, divide -1 by 1/2. The calculation results in a new slope of -2. This negative reciprocal dictates the exact orientation of our new line, ensuring the two paths remain perpendicular. To build the actual equation, we use the point-slope formula. This formula allows us to define a line as long as we have one point and the slope. We now combine our known variables, the target coordinates at -1, 2, and our new slope of -2. First, we substitute the y value of 2 and the slope of -2 into the formula. When we insert the x value, we encounter a double negative because we are subtracting -1. Those two minus signs become a positive, giving us x plus 1. Correctly handling this specific sign change is exactly what ensures the equation remains completely accurate through the final steps. Now we simplify the equation by distributing the -2 across the terms inside the parentheses. This gives us -2x minus 2 on the right side. We have a -2 on both sides of the equal sign, so they cancel out. The equation is now simplified to y equals -2x. To match our original problem's format, we rearrange this into general form by moving the terms to one side. Moving the -2x to the left makes it positive. This gives us the final corrected equation, 2x plus y equals 0. This finalized general form is the mathematical solution to the problem. To confirm the result, we can move from algebra to a visual graph. Here is our original orange line plotted on the Cartesian plane. We plot our target point at -1, 2. When we draw our new blue line, 2x plus y equals 0, it passes exactly through the target point and crosses the orange line. Zooming in, we can see the intersection is a perfect right angle. The square icon fits the corner exactly. Seeing the lines intersect in this way confirms that our algebraic steps were completely correct. The problem is solved.